When you have a Zephyr device plugged into your computer using USB, you probably want to do things with it, like send a firmware update or access the file system. And you can do that using tools like MCU Manager, SMP Manager, and a range of other tools that are out there. Those are enabled using a protocol called SMP, which lives under those top-level applications. Today, we're showing a new tool that uses web serial to deliver SMP packets to your devices and ultimately send firmware updates and manipulate file system through the browser. We call it the local shell. Since my first day at Goliath, we've been working on making embedded devices easier to use when you're building IoT things. And web serial is one of these tools that can really enhance that. Really exciting. Firefox has recently introduced the ability to do web serial in that browser as well. So now we have Chrome or Chromium-based things like Chrome and Edge, now also Firefox. And really, it's just about lowering the barrier for devices to connect and do interesting things. We find it's useful for things like training, onboarding new devices, but there's still a piece that was missing, and that's what we're going to talk about here today, called local shell. Local shell is a evolution of a different idea we had called remote shell, and so that's something we did a while back here. Remote shell was basically the ability to go and talk to devices using Goliath RPCs over the internet, but it looked like a shell, right? It was in the browser, it looked like a shell. That actually talked over the internet to cellular devices, really any Goliath device, and then it could send the data back up using a custom backend in Zephyr. We really like the shell capability in Zephyr and the ability, in this case, to talk to it remotely. But what if we wanted to do it locally? Well, that actually is possible already. It's possible because you're just plugging in over serial or USB CDC. You're talking to the device over its shell. But now today we're going to talk about how we can do that using web serial as well, and also do other things like manipulating the actual file system and the firmware on the device. So let's talk about that. We're going to be talking about this setup here, but what I really want to point out first is this right here, which is the USB cable, and really just the connected nature of most IoT devices at the beginning of a development process. Usually we're first talking to it over a programmer, but then usually we're talking to it, powering it over USB, talking to it over USB, talking to the serial interface, talking to the shell through the serial interface, and this is just how a lot of IoT devices work. You're usually working on them locally first. And so that's where a lot of this local shell made a lot of sense. But sometimes our users are approaching Goliath with an off-the-shelf device, like maybe like this Thingy 91X in the back, or other commercially available development kits, and we want to get them started a little bit quicker, and they might not actually have a programmer on board. In fact, this device back here, it actually doesn't have a programmer. You need to have an external J-Link to talk to it, which is great. You don't want to load down every device with a programmer necessarily, but we still want to talk to the device itself, and so we want to talk to it potentially over serial. Again, lowering the barrier, making it easier for people to load this stuff up onto their devices. We want to do that with something like web serial. Now, it's not without any tooling that makes this work. First off, we're going to be talking about devices that have MCU boot as the bootloader, and you can push in new stuff using the serial interface to that bootloader. That's going to be one of the things that's required here. Another one in this case, especially with Zephyr-based devices, is the shell, and so that's something you can compile in. Both of these things, actually, you compile in as part of your Zephyr program, and we'll have some examples we show. But ultimately, these are the things that you are going to be talking to over web serial. So we're going to be enabling serial interface using the shell, and we're also going to be talking to the bootloader over that serial interface as well. So both of those things are required. Enough talking for me. Let's actually go and build this and show it on the bench and show all this stuff lighting up and talking to the browser. Right here, this is the remote shell that we showed in this blog post. You can go and read that. We'll have that link below as well. But the remote shell looks eerily similar to the local shell. Really, the interface doesn't matter. I was just, had the LLM text make it look like iTerm on a Mac. You can make it look like whatever you want it to, but ultimately these buttons down here are the interesting thing. Once again, we're going to be interfacing with the this device here. So this is a Bluetooth board called the Teak. That's what we've been working with a lot. This has an MCU bootloader on it. It also has a file system, and probably most importantly, one of the reasons that also drove a lot of this interest from my side is that Goliath requires certificates for Bluetooth-based devices to use pouch and actually encrypt that data. When we wrap it up in a pouch, it's encrypted. That then goes over through a gateway up to the cloud. And the interface to load up pouches is normally done using something like MCU Manager, SMP Manager, but what if we made that a little bit simpler? So first we're going to just go and talk to this device. We're going to open up a serial terminal using the USB here, and we'll interface with this device. This is the teak board that has LEDs on the front. On the back side, there's an NRF52840, and it's got a USB CDC connection using its USB port, and that's talking over a virtualized serial link out to the computer using that. Back here is a cellular gateway. That's actually going to shuttle pouches, Bluetooth pouch packets through this Bluetooth link here up to the cloud using cellular data. But the first thing I'm going to do is actually go and connect to this device using the USB. And so what we see here is we see once I hit the connect button, it opens up the serial port interface. This is Web Serial. It connects just like we would if you were doing Minicom, Teraterm, any of the USB to serial, any of those serial terminals you might have on your computer. But in this case, this is Web Serial. And so I'm going to go and actually activate this device by just tapping. There we go. So you see it have a single wake up event. It's going to wait 10 seconds, and then it's going to advertise data using Bluetooth, talk through this device up to the cloud. So we should see that connect. And now it sent that up. It turns off the light once it's actually sent that data up to the cloud. And now that's good. Okay, so that's just basically monitoring. We can also send data in here. I could type help. I can see all the normal interface that we would have with USB serial with a shell from Zephyr. So there's a bunch of things that we've compiled in. We've compiled in the sensor subsystem. We've compiled in the I2C, helper, GPIO, the file system. All of these are optional things you can compile in Zephyr, and we've done that, and so we can go and interface with that. And we are going to use the file system one here in a second. First thing I wanted to do is show just this data connecting here. You can see this is the name of this. If I hit restart, it's going to be, it would show its certificate name, which is DK currently, and Thingy91X is that is the gateway that's sending the data up. This is showing just that it has been taking some readings, but they're actually not valid right now because of the firmware that's on there that can actually take the right readings as well. All right, let's go and create a new device. So I'm going to actually go to the devices page. I'm going to hit create, and let's just take the default name here. I'm going to say create. I'm going to create a temporary certificate. And so this is going to use the common name here, Emerald Chronic Hookworm. This is the project name. Hit generate. It's generating a temporary certificate, and then it's going to allow me to download both the public key and the private key. And I'm going to close here. All right, now I'm going to go back to this Web Serial interface to the device, and I'm actually going to delete the certificates that are on the system. So I can do FS as the file system, FSLS. You can see what's on here, and so you could just crawl this like you would any other device. It should be credentials, and we should see there's a crt.dir and a key.dir. So I'm going to do fs remove lfs1 credentials key.dir, and then I'm going to do fs remove lfs1 credentials crt.dir. Okay, and I should see nothing in here now if I copy this, paste this in here. There's nothing in there now. Great. And if I go and restart the device, we will see a disconnect from the Web Serial interface, but we will see also that the certificate has been reset. So no cert. Great. Okay, I just reloaded the terminal here. I'm going to also reload this device just to show that we're showing this again. And so there's no certs in there. We could go and connect, but really I want to actually just go and hit upload certificates. So I'm going to hit upload here. There we go. And now I see these are the two of the files that I downloaded. So I'm going to do key.dir. Hit that again. crt.dir. And now those are in the background. Now you're going to see this disconnect again, but we should see the new common name, Emerald Chronic Hookworm. All right, there we go. So this now has new certificates on it. It does also still have the file there. So what actually happened there? I suppose the thing that is newest here is the web serial interface over SMP, right? So we already had web serial. That's pretty standard. Basically, you connect a serial device, you can talk to it over web serial. The thing that me and LLM coding assistant worked on back and forth over multiple generations of different models coming out, the SMP interface was the tough one. Now, we had the reference implementation. So SMP Manager is a Python-based reference implementation. There is a Bluetooth SMP web Bluetooth implementation. That's actually another interesting project that's out there. And there's also MCU Manager, which is a Go-based implementation implementing the SMP protocol. So this is basically the packets that get handed back and forth to the device. Again, it's not just ASCII out using the serial. It's actually this encoding scheme using SMP, and that was the thing that kind of took the longest here. And that's actually what's happening. So when I uploaded that certificate, it's actually talking SMP over serial to the device itself and pushing stuff into the file system there. And so that's really the interesting piece there, because that also means that we can use that same thing to push SMP firmware updates down as well. You might be asking, as some of my coworkers do as well, why do this? Goliath has OTA capabilities, and that is correct, actually. That is one of my favorite features of Goliath, and the reason this is interesting is that this uses the same bootloader and actually just talks to it using a different protocol. So when Goliath sends you an OTA update over over Bluetooth, over cellular, over whatever your connection mechanism is, it's basically loading that firmware over that link. So just to use cellular as an example, we send CoAP chunks of data using CoAP over cellular down to your device. That then gets put into a memory partition, and then we talk to MCU boot. It loads it back out of that new partition, and that, boom, you have your new firmware update. If you wanted to manually push that into MCU boot, though, you have to do that basically using something like SMP. And actually, there's other tools out there that do the same kind of thing. Again, you can use SMP Manager, you can use MCU Manager, you can use NRF Connect for desktop, but I have yet to see this actually work through a browser. And so that's where the local shell comes up. Again, the reason that this is interesting to me is that we can actually have someone go and buy a device off the shelf, a dev kit or similar. We can hand them a file, we can point them to a website, and they can go and load a new firmware image directly there. So you think about maybe, in the Goliath case, we're talking about training and onboarding and simplified stuff there. But if you're a developer building something for an end user, you want to be CRA compliant, you want to be able to push new firmware updates, maybe in a place where there isn't connectivity as well, right? I want you to have connectivity. That's what Goliath is great at. But maybe sometimes you don't have that as well. Well, you could do that using web serial and now with SMP as well. So let's take a look at what this looks like to upload a new firmware image. All right, so we're back in the interface. We can see after we had done the certificate upload and I had hit the reset button, we actually did lose that connection, but that's no problem. We can just go and reconnect here. Instead, we're going to actually go and do a firmware upload. So the first thing we have to do is actually put it into bootloader mode effectively. So we need to do that by pressing the boot button and the reset button. Then I let go of the reset button, and then I release it there. And what we'll see now is that when we hit the upload firmware button, it prompts you to do the same. Now we should see the device name as MCU boot, which we do. Great. And you see there's actually two devices here, but we're going to use the first one, I believe. All right. And now it should be asking for... There we go. Now it's actually asking for a new firmware image. And so this is, I dropped the 1.3.0 into here. Again, this is binary. And so you'd see there's a loading bar down here. Again, we still have the certificates on board. We are basically just pushing in a new 430 kilobyte image here. And this is all happening over SMP, talking to the MCU boot that's on the chipset there. So no programmer required, no debugger, anything like that. It's just going over the serial link, which is great. All right, almost finished. All right, so let's try and hit the reset button. There we go. So we still have the certs on board. Those are stored in the non-volatile flash, the same one that we loaded up there. with a long name. Should have made that shorter. And now we should also see version 1.3.0. Boom. All right. Yes. And this now is just a different version of that same firmware here. We should hopefully, well, we can try and reconnect here. No, that actually got a connection from the, that's actually the connection from the cloud. So that was coming through the gateway back to the Bluetooth device here. We should be able to see, let's go connect to it here. You see the name change back to the USB dev. And we should see basically the same behavior here. We also should see the, here we go, pouch demo 1.3.0 as well. So that is now in there and talking to the device. And let's try and send a new setting down. Hello, web serial. Okay, so now we have to make this connect one more time here. So again, we see the single connection here. This, you can kind of see it flashing in there. This is a bug to be debugged using web serial, but now it should go and again connect using Bluetooth to the cloud through this gateway again. Once it then gets the download, we should see hello web serial. There we go. So what have we seen here? We have a interface, that kind of a multi-tool that allows you to talk to your embedded devices using serial, using web serial, and so you could do that without any customized tooling on your device. Hopefully you can do that regardless of what your network policy is. One thing that inspired a lot of this is we don't know what people are allowed to install on their computers, but web serial and Chrome or now Firefox makes it a lot easier to kind of level that playing field and make these capabilities there. We also can load in certificates, right? And certificates are a best practice for making devices more secure. We have always shown pre-shared keys and pre-shared keys IDs, and that is still possible, but not great for production. We think that certificates on non-volatile storage, we probably don't want our private key there. We'll have some stuff we'll talk about in the future there as well, but this is another good step up from that as well. And all of these things make it so you're making more secure devices, you're connecting things to the internet, and now you're able to work locally using this multi-tool. So load your first firmware update using the local shell, load up your certificates, connect to the cloud, and then you're already into a method for pulling OTA because you're connected up to the cloud and Goliath. So if you have any questions, you can always go ask down in our forum. Hoping to put out more tools like this to make things easier, to lower the barrier to getting started with Zephyr devices, other devices that are out there, anything that works with Goliath. We want to enable using tools like this, and we'd love to hear what would help you out as well. So head over to the forum, and we'll see you in the next one.